Hello friends, today I am going to discuss some previous topics like machine learning for forecasting. So I have already created a model because we need to take a less time. So let's see, machine learning for forecasting means forecasting already we needed to some data, and now if you want to the forecast what happened after a week, after a year, because you have already the past year data, and now you want to the forecast future prices and something. So most of the time in the recent year, just the computing power of the computers has become much more commonly available, so we can easily create a forecast and these things through today we are using artificial intelligence. So artificial intelligence, especially the machine learning, can be used for the wide range of tasks including robotics, self-driving cars. So this is a way so to discuss these things. So first, let's see, just we have a data like simple data and purely just a hypothetical examples for a forecasting the average price of a cup of coffee in an the imaginary city, like some city's name, you can say the x, y and y something. So let's see, I have taken a first I am going to import the pandas as a pd and matplotlib dot py plot as a plt. These are the two library, and I am going to create a years, another is the price as a list, and now it has been stored like the data will equal to pd data frame and parenthesis again start like this brackets is create a dictionary year and years and price and prices, because year I have taken and another is the price I have taken. So let this type of the data, and now ax will equal to data dot plot dot line. So x represent as a year and ax dot set underscore title represent as a copy price over time. And now the font size means size I have already discussed in the matplotlib. Okay, so I am plt. So let's see, just I am running this data in front of you and I can see your output. So year represent here x axis and y it has been represented as a price. So this is a linear graph. So the hypothetical example, so the price of the cup of a coffee over a year. So in this data clearly it shows the increase in the 20% here, 20 cents in the prices every 5 years. So this is a linear increasing trend, and linear because it is increasing with the same amount of every year. So increasing because it becomes the more rather than less. So in this data, just Python to see how to plot this linear increasing trend in this graph. So how to see how to plot this linear increasing graph. But now I am going to look here some of the copy examples, and now I am going to the plot here the same thing. Some numbers has been given, another just I have taken the another example, and now to predict for a price of the coffee in this hypothetical some cities. So we could just put some label like a graph, and now the continuing the upward lines and downward lines. So the predictions for the variables does not need to the any explanatory variable other than its past value. So historical data. So let's see in this data here, some characters means seasons has been given. So you can say that this data like a time series model. So the now season has been given and seasonality price has been given. Same, there are two data. One is the season's name has been mentioned until 2018 to till 2020. Now price has been given each season, and data has been created pd dot data frame just as a previous season and seasons and price and price. This seasons has a represent as a season and prices has been represented as a price. Now I am going to here ax will equal to data dot plot dot line x represent as a season and ax dot set as a title, because chocolate price over the font size 16, and now another is the as I said x tick labels, just ax dot set get and x tick labels something, and rotations as a your name must be written as a 45 degree, HA means right side, and plot this one. So this has been plotted here, and this one is the 45 degree, name has been mentioned this way. So you can see the trend. So the trend of this price is increasing and decreasing according to the season. So easily detect the seasonality. You can say here hot chocolate price. Now next, so previous example and this example you can see the differences. Previous is as is the linear and second is the this one is not a linear. So this can predict the future price, the hot chocolate, easily using the past data, the hot chocolate price. Sometimes you can discuss other univariate time series models. It makes the predictions based on a trends and the seasonality observed in their own past and do not use explanatory variables than the target variables and the variables that you want to forecast like this. So you can also apply just different types of combinations of those to the process like a quarterly, half yearly. Okay, so you can easily understand. Another way, just first you have to understand, because like you are going to discover the different approach for making some models, and sometimes the approach is not logical. Processing do not always follow trends and seasonality. So some predictions that you want to make may be dependent on the other independent sources of information. These are called explanatory variables. So you can use of a method called a supervised machine learning. So let's see the first understand what is the supervised learning. So to understand the case here, like you have some quarterly results has been the quarter 1, quarter 2, it has been given, and sales has been given, and the data you can easily frame work like a pd dot data frame, and quarters as a quarter, sales and sales. Now ax will equal to data dot plot dot lines and x will equal to quarter, and another x dot set underscore title, it has mentioned the title, and font size it depend on you. So similarly these are the look like a previous year. So two things given, one is the time period and another is the quarterly sales has been given, and we have already created data frame, and now I have gotten here the output is this. So your graph like a obtained this one, sometime is increasing 2019 first quarter and third quarter it is look like a decreasing. So we can easily means you will print this line of the graph, so like you the time durations you can say easily in which quarter is increasing and which quarter is decreasing, and you can follow in the future quarter is also same way you can. So let's see. So what you can see in this graph does not resembles the previous example. So there is a no clear linear trend, so neither increases and nor decreases. So and there is no clear quarterly seasonality either. So now if data about the sales and look like a explanatory variables that could help in the explaining a sale. So need to the first, because we have the only two data, one is the periods, another is the quarterly sales, so we can easily get the average discount, average budgets. So the data have been updated in the two explanatory variables, one is the discount, another is advertising budgets. Both are potential variable and that could influence the sales numbers. So then just look here, I have taken one is the quarter, another is the sale, or already I have taken. Now I am taking one more data as a discount, another is the advertising. So then we can create this this one is the previous and another is the previous. Now discount has been added and advertising has been added. Now I am going to the created data pd dot data frame, and quarters are just previous, sales and sales already previous, discount we have taken just this time, advertising has been taken. As it is just a previous process I have followed, and now we can see here this type of graph is a display, and graph display like a development of the three variable lines. One is the sale, another is the discount, and third is advertising. So at this point we can see, we can say that there is not a very important relationship between the three variables. But we can say it is it is a more zoomed, like a look at the same graph, same just I have taken again here 4 things, but now I am going to use here, look here, just I am going to apply, because all the things has been taken the same, but only what happened, just a previous data look here, because advertising is a like a big amount. So look here, one value is the discount is the 4, it is in a percentage, sale is the 48 cr, but 500, but if I am going to multiplied with the 10 is a discount. So let's see, the discount scale has been adjusted, so x has been adjusted with the 10, we can multiply here 10, so for the x in a discount, so your advertising has been, if you can multiply here, it will be like a 5,000. This one is so, and other thing, just I have multiplied here. Now I am going to the advertising scale adjusted x divided by the 10. So advertising I am going to the discount means reducing here, and discount we can multiply here. So this one, so you can see the properly your graph. Yeah, you can also multiply other 12, no problem. And now after that we can see, look like this, your graph has been now you can see the good relationship sales, discount and advertising. So you can suddenly observe a very clear relationship between three variables. So the relationship was the already there in a previous graph. So we need to the adjust the sometime values. This is the most important thing, and this is the good way to. So you observe as a correlations as a strong. So if you have to do this sales forecast for the next month, so you could simply ask the what is the average discount is going for the next month, and what the next month advertising budget is, and you can you would be able to come up the reasonable guess of the future sales. So now the this type of relationships is the what you are generally looking at when doing a supervised machine learning, and intelligent use to those relationship is a fundamental idea behind the different techniques that you will see next. Just we want to see the some correlations coefficient. So I think correlations means we can easily look here. Just I can see the sale, discount and these three advertising. So sales and sales, the correlations 1, because both are the same here. Sales and discount between the correlations 0 point. So good, these are the positive correlations, and all are the positive correlations, because 80 more than 85, these are the called positive correlations. So what is the correlations? Just a visual way to detect the correlations is a great, and there is a more exact way to investigate the relationship between the variables. So the correlation coefficient is a very important to the measure in the statistics and machine learning. Pearson's correlations and something. So you can learn through a statistics textbook. So the correlation coefficients between the two variables, one is the x and another y. So you can get the need to the two variables. So the correlations matrix we have already generated here, like a matrix means row and columns. So the matrix that it contains the correlations between the each pair variables, and we can easily predict. So if my sale has been increases, if I give a discount, and if I expand my expenditures is doing like a more on advertisements, right here. So correlations coefficient always between the -1 and 1. So the positive value of the correlations coefficient means the two variables are the positively correlated, and if I am working on the one variable, so another variable also affect the very well. So similarly, if the one of the higher than the other is the generally also higher. So if the correlations coefficient is the negative, so there is the negative correlations, and its value is the higher, and then other is the generally lower. So this detections of the correlations. So now strength of the correlations we can easily understand. If you write here the 0 means this is the weak correlations. So in these circumstances we can see the variables, we see the going the positive correlations between the sales and discount. and a strong positive correlations between the sales and advertising. Sales and advertising. So the correlations is strong, so they could be useful in predicting future sales. You can also observe a strong correlations between the two explanatory variable, discount and advertising. Is this? So this is the important to notice, the because of the two explanatory variables are the very correlated, it may be a little added the value to use them both, and they contain almost the same information. Let other is the machine learning. Just I have discussed supervised and then unsupervised. So first, what supervised models are all about. So, but there also unsupervised model. Unsupervised model is a different from all approach before, and there is the no target variables in unsupervised model. So unsupervised model are great for making a segmentations. So a classic example is the regrouping customers of a store based on the similarity of those customers. So there are the many great use cases like segmentations, but the approach is not generally useful for castings right here. Another you can also have to understand, we have to understand the classifications and regressions model. So now the inside of the group of the supervised model there is an important split between the classification and regressions. Regressions is a supervised modeling in which the target variable is a numeric. In the example that you have seen in the previous sections, there were only the numeric target variable, and they would therefore be considered a regressions. So classifications and the target variables is a categorical. So classifications is a predicting whether the specific customers will buy a product based on their customer behavior. So there are many importance used to the cases of the classifications, but when talking about the forecasting the future, it is generally the numerical problems and therefore the regressions model. So think about the weather forecastings rather than trying to predict either hot or cold weather, which are the categories or weathers. You can try to predict the temperature numeric, and instead of predicting the rainy vast dry weather category is, so predict the percentage in of a rain. Another we have to understand the univariate and the multivariate models. So we have seen just like a you can say the sometime we try to understand the target variable like a sales, but in some cases you want to predict the multiple related variables at the same times. So just like a social media, so you may want to forecast so how many likes you will be received, but also how many comments. So this type of like a multi-variable. So next here, just how to evaluate a model. So model evaluation for forecasting, you can say just whenever if you are developing a machine learning model, and yeah, we have already the developed machine learning model, so and you are applying it, but you can see means you generally benchmark the multiple models during the builds phase, and then you can estimate the performance of those models and select the models which you consider most likely to perform well. So let's see the evaluations same thing, just we have already imported, and time period means period I have taken just name of this month. It will start from the January to December, actual already given, actual price, and forecasting already we have done. So there are two, one is the actual numeric value, another is the forecasting. So of course just actual and forecasting you can get some differences. So evaluate in this example. So assume the forecast has been made in the December some year, means 2022, and for the complete of the year it is not has been the updated since. So let's see the 2019 we call previous year, and now I am going to the forecast here. Let's see what happened. So I have taken and it has been forecasted. So this one is the actual price and this one is the forecasted price. So let's look the purely hypothetical example, the stock price of the month of the year 2022 and the forecast the sum has made for this. Assume that this forecast has been made till the November and December. Yeah, right, December but 19. Okay, so the completely the years has not been updated like so. So first we had only the two data, one is the period, another is the actual, and now I have created this type of, but this information means we have already displayed the actual values against the forecast value over time. Now I am going to get here something like errors. So we can easily here it is intercepting, but here we can see the differences between these two value, forecast and the actual value. So let's try to model quality matrices. Matrices in suppose this month by month error is a useful informations for a model improvement. So through it gives the first impressions of the quality of a model, and there are the some problem with this way the model evaluation. So first the level of the detail would be too much and to do a model comparison, so you cannot look a long list of error for each model. So second, you should note that it is not simply possible to take the average in this error column and consider this as your error matrix. So since there are the positive and negative error measures, so so they would average each other out, and this would be the strong underestimate of your error. So let's solve this problem. You need to standardize the error by taking the absolute value or squaring the errors. So first we have to make sure that the negative or positive error do not cancel each other out. So first we have to understand there are mostly we are using 5 common matrices and try to understand. So first is the MSE, mean square error. So mean square error is look like this. So what is the mean square error? Mean square error is the one of the most useful matrices in the machine learning. So it is computed the average the square error. So completely mean square error. So we can take the error per row of data and square those error. We can take an average time. So let's try. Just I try to write here. Is it possible? You can understand. So MSE yeah, MSE will equal to 1 by n bracket start, and before bracket you can use the summation, and y you can say I minus yi cap. So y and to the whole square. This is the mean square error. So this means mean square error can take the error from the row. So let's see, just we have a data, so we can already the previous and need to the create the mean. So mean, how do I get the mean? So y mean we can get here y1 plus y2 plus y3 and dot 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 and whole divided by the n. This is the mean. So you can get this value. So after that we can subtract and then edit out these things. So I think your concept has been clear. So I am going to erase these things. So same process, if I am using like a Python, and we can do within a second. So first I am going to import here from sklearn.matrices import mean underscore and underscore error. Now the print mean square underscore error and data actual I have taken, another is the data forecast, and now we are going to use here. So within seconds I have gotten mean square error is the 53.66 means you can say the 7. So the current exam means the logic behind this error matrix is multifold. So first we can understand the reason that the square error are used rather than original error, because it has been subtracted from the original. So it would be impossible to the sum of the original error. It would be impossible to sum the original error. So since there is a positive or negative value in the original error, so they can cancel each other out. So imagine a case with the one of the large negative error and one the large positive error. So the sum of the two error might be close to 0, which is clearly wrong. But the square of the value is always positive, which is the why this is one possibility to counter this. Now the second part of this formula that it can be the understand, that is the functions of and the average. So you talk the sum of the all value and divide by the numbers of observations in the mean square error. So mean square error matrix is a great for the comparing a difference model in the same data sets. So the scale the mean square error as the same the each model applied the same data sets. So let's see if I try the mean square error matrix. So mean square error as it is same here. So mean square only the under root of the, so mean square is in the error matrix, so it should be the interpreted as a follow. So the smaller the error, the better the model, so it is not possible to convert this into the accuracy measures. So because of the lack of fixed scales of a matrix, there are no upper bounds to the error. So it should really be used the comparisons only. Next, RMSE means root mean square error. Root mean square error will equal to under square of this mean square error. So under square of the mean square error is called root mean square error. So let's see, just I am going to write here this formula. And then so I am going to write here R root mean square, R M S E will equal to underscore M mean square error, right? So now I can erase here. So I hope we can understand, and same way just we can easily try to remove within a second. We can do this process. So root mean square error is as it is the same, you can say, and I am going to try here. Let's see, I need to create here. Okay, yeah, look here, same, just I have import the from the sklearn matrices import mean square error, and from the math import the square, and now I am going to write print square mean square error data actual and data forecast, and I have gotten here 7.3. So if you compute the root mean square error, and you can see this, so this is the much more in line with the actual stock price. So you are working with, so you can have an advantage for explanations and communication purpose. So other things, just next matrices is a MAE, means mean absolute error, calculate and taking by the absolute difference between the predict and actual value per now. So the average of those absolute error is a mean absolute error, so we can write as a modulus. You can write in a modulus, look like this. So let's try here. So MAE will equal to 1 by n and summation modulus yi, just I have discussed yi and yi cap in a modulus. So MAE takes the absolute value of the error before averaging and taking the average of the absolutes, and this error is a way to make the sure the summing of the error will not make them that cancel each other only. So another way, so we have gotten the same here. Let's see the from sklearn dot matrices import mean underscore absolute underscore error as, and another the print mean underscore absolute underscore error and data actual and another data forecast. I have gotten 5.66. So mean absolute error using the square of the error and avoid this. So mean square error is the alternative to this MSE. So you can mean absolute error means Python using and this code, and you should obtain 5.67. Similarly, MAPE, another MAPE means mean absolute percentage error. Mean absolute percentage error, as it is the same, but it will divide by the yi. So this one is look like the same, but only previous value has been only divided by, this one is a divided by, we write here the modulus, this one you write here only a modulus, you write here a modulus, and this will divided by summation is the outside of this, summation will be here, and this will divide by yi. Okay, so this is called mean absolute percentage. It is the computed by like taking and the error for the each predictions divided by the actual value, and this is done to obtain the error relative to the actual value. So now you can understand from the previous error measure, and they were the not the standardized like a scale between the 0 and 1. So let's see, just I have gotten here and from sklearn dot matrices import mean underscore absolute underscore percentage underscore error, and I have written the same here, print mean underscore absolute underscore percentage underscore error, and data I have written here actual and data forecasting, and I have gotten 0.46. So you take the absolute value of the those, the percentage means 46%, and per row and compute their averages. So MAPE measure the percentage error, so it is an the error measure, so the lower value for the MAPE are better, so you can easily convert the MAPE is the goodness of fit measure by the computing 1 minus MAPE. So in the many cases it is easier to the communicate a performance of in a terms of positive result rather than negative result. So there is a one drawback serious MAP functions is intuitive, it has a serious drawback when it is the actual value 0, the formula will divided the error by the actual value. Next, and this one is the matrices R square. R square very important matrices that are the very close to the 1 minus MAPE matrices. So R square as it is the same here, but only differences is 1 minus. So R square will equal to y 1 minus summations yi minus yi cap square, and similarly it will be divided by the y minus yi. So it looks like the formula sometime. So from sklearn dot matrices import R square underscore scores, and now I am using and I have gotten the 0.39%. So the formula does interesting and computation, so it computes the ratio between the sum of the square error and sum of the deviations between the forecast and average. So it comes down to the percentage is the increases of your model over using the average as a model. So if your model is a bad predictions as using the average, then R square will be 0. And this time today most of the stock price forecasters are using to predict the price of stocks. So let's see, just 39% means approx we can say the 40%. So this give you the value of the 40. So as R square is a measured on a scale between 0 to 1, so you could translate like a 40% better performance than the average, although exact the interpretations will not be a very clear for your business partners and managers. So these are matrices. Just after that, just if you can gotten, if you have gotten like a R square, then you need to do the evaluations strategy, model evaluations strategy. So now we see just a important whenever we have seen already the 5 important. So how to set up for a model comparisons. So you are doing just advanced forecasting, so you will often be working with a lot of models at the same time. So there are the lot of models, and you can use the remainders, and you can do more practice. So let's see, first questions has been arising here, how to decide which model is most accurate. So because multiple models to predict the short futures and wait for see one work best. This does happen in a practice, and this is a great way to make sure you deliver quality forecast. So however you can do more. So second, how to decide which model is the most accurate means without waiting. So let's see the overfit and out of sample error. So need to understand overfit and out of the sample error. So when doing a forecasting, you are building a model on a historical data and projecting a forecast into the future. When doing this, it is important to avoid a certain bias, a very common bias, and it is a fit model on a historical data and compute the error on the historical data, and if the error is a good, use it for forecast. So just I am using the machine learning model and are the powerful learning model. So we will learn first thing, train test split. So train test split means the first split is a open deploy is a train test split, and when the applying the train test split. So generally we keep 20% and 30% of the data as a test sets and remaining for training sets. So the you can now, so we can proceed to the fit models on the rest of the data and the training data. So you can apply the many models to the train and learning of this model. So let's see the model of the higher scores and this one. So training and testing. So I have created the training and test. So from sklearn dot model underscore selection import and train and test split here. So I have taken y as in the data actual. So train or test. So I am going to splitting the 30% for the testing model, and another train mean. We have gotten the train mean, and then data frame as a train and train forecastings, and now the train error mean square error I am going to apply here, and another like a train forecast here, and third thing you can use the test and pd dot data frame test and forecast test error and mean square error and test actual and test forecast, and print and train error and test. So after that I have gotten here 122.93. So this means the train error is 122.93 and test is the 32. So after here one of the data, the train test split will cause a problem. So the training data will not have full year of data, so which makes the model to not fully learn any seasonality. So in addition, you should strive for having a list the 3 observations per period. So in this case the 3 years of a training data. So generally a good idea to take a seasonality into the account when the selecting the testing a period. So in non-forecasting situations you will often see the test 20 or 30% data. Forecasting, I advise the using the full seasonal period. So if you have a yearly seasonality, so you should use a full year of the test period and avoid having the model that works well in summer but badly in a winters. This type of the model don't take care. So now I am going to use here the train validations. Next I am going to train validations when doing a model comparisons your benchmark to the performing the many models. So adding the approach, we can add the extra split like a validations split, like a hypermeters using the model types. So let's see the splitting. Here the 70% of the train, 50% of the validation, 50% of the test. So train, test and splitting in the data, actual test and test. So I have taken these things and now it is going to, yeah, so it has been fixed. Similarly the fit, the estimate the 2 models of the train data, forecast the mean and forecast here the median, it has been taken. And now the mean square error validations data, the both the models, this one has been taken. So let's see. And now you observe the following validations. So I think mean value variance is the 23 point something, look like, yeah. So here we can follow, means we can observe the validations mean square error for the mean model is the 23.56 and 9 another just mean square median has been 91.25 the median model. So this would be the reason for to the retain the mean model against the median model. So as a final evaluations you are verify the whether the validations error is not influenced by the selections of validations. So set that the favorables and to the mean model. Now you can use the cross validations. So this one is the cross validations. Now the data frame as a test and forecast mean. So let's see, just I am using here, and this one is also called the problem with the train test sets may occur when you have a very little data, then you can use the cross validations, because that time you can say in this case you cannot afford to the keep the 20% of the data apart from the models. So in this data, because this is a very small data, so we are using here cross validations. So let's see the 41.31% and now use here the cross validations. K4 here, yeah, 106. So this is the mean square error, so it should be only the compared with the error of the other models as the same data sets, right here. So let's see, just I have used this model, so you can understand. Similarly, the time series cross validations model I am going to use here. Another is the time series cross. So same, I have imported from the sklearn.model underscore selection, import the time series split and TSCV, the time series split and error for the train index. Just I have done. So look here, this one is 194.56. So this method is the cross validation estimations of the error 194.7. Again, so this error should not be used as a stand-alone, but as a way to compare the performance of the multiple methods, same data. And rolling time series cross sections means alternative that has been the proposed, the rolling time series split. So it is used for the same period. So let's see, just I have imported from the sklearn.model selections, import the time series split, and just I have written these codes. So let's, and now I am using here code like this 174. So this method model evaluations estimate of the error. So you have now see the three cross validations error we have already discussed. The all are different. So each of them uses the same model. This tells you two things. Firstly, it insists on only comparing the error estimates using the same matrix, using the same data sets. Secondly, you have observed a significantly the lower error in the rolling time series split. So this may be a hint that using the model with a very little historical data, so could be a more performant model in this case. So now you can easily understand. This is the great way to can understand. I hope it will be helpful for everyone. Thank you.